Measuring matter. Matter can be measured by count, using numbers or grouping, like dozen, mass, by kilograms or grams, and volume, liter, cubic centimeter. We can also convert matter from one unit to the other, just by having the proper conversion factors. In here, I'm providing the conversion factor from 1000 x to x, that is 1 to 12, from 1000 x to kilograms, that is 1 to 1.5 kilograms, and the conversion from 1 kilogram to 1.56 liters of x. Now, it's your time for you to try, and please stop the video and do the two problems that are here below. Then play the video and you'll see the answers. Good luck. Measuring particles. In chemistry, we use a lot what is called representative particle. And a representative particle is an atom, a molecule, or a formula unit. Another way to measure matter in chemistry is to using moles. And 1 mole equals 6.02 times 10 to the 23 representative particles, which is called the Avogadro's number. If we want to convert representative particles to moles, as we know, we will need to multiply times a fraction where the representative particles will be placed at the bottom and the moles, what we are looking for, on top. In contrast, if we want to convert moles to representative particles, we will multiply times the moles at the bottom in the fraction and representative particles on top. Now, it's time for you to stop the video and do the next problems to see if you did understand the concept of representative particles and moles. After you stop the video and you do these problems, play the video back and you'll see the answers. Good luck. Meet our guests. Molar mass. Molar mass is the mass of a mole of an element or a compound expressed in grams. To be able to calculate the molar mass is the mass of an element or a compound, you must remember the next. The atomic mass of an element expressed in grams equals the mass of a mole of the element. If you remember, in the periodic table you can find the symbol of the element, its name, the atomic number, and the atomic mass. This atomic mass equals to the molar mass of the element in grams. Remember one thing, the atomic molecules are always found in pairs: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Thus, to calculate their molar mass, the atomic mass should be multiplied by 2. The examples below, you can see this. For hydrogen, as you know, is a diatomic molecule, so it's H2. The number of elements is 2. The molar mass of hydrogen is 1. Thus, multiplying 2 times 1, that will give us 2 grams of molar mass. For oxygen, is the same situation, is 2. Times 16, that will give us 32 grams for oxygen. Remember, this is only for diatomic molecules. Now, it's time for you to show if you did understand the concept of molar mass with the next elements. Stop the video and use a periodic table for these problems. When you are done, click play and you'll get to see the answers. Good luck. Now, what happens when you have compounds? When you have compounds, you have to calculate the molar mass of the compound by following this chart. First, find the amount of each element in the compound. Then, find the grams of each element. Then, multiply the number of grams times each element times that appears in the compound. Finally, add them all. Let's do an example so you can picture this clearly. If we are looking for carbon dioxide molar mass, first we have carbon and oxygen. The number of elements for carbon is 1 and for oxygen is 2. The molar mass For carbon is 12 and for oxygen is 16. Multiplying times the number of elements, that will give us 12 for carbon, 32 for oxygen. Adding them all, that will give us 44 grams, and that will be the molar mass of carbon dioxide. Now, it's time for you to try to show that you did understand the concept of molar mass in compounds. Stop the video and do the next problems. When you are done, play the video back and you get to see the answers. Good luck. Remember, diatomic molecules are always found in pairs.